Hello students, welcome back to my channel. Today I will be discussing about acids, bases and salts. This is the first lesson of this topic and this topic is common for students from all the boards. So let's start the lesson. In this lesson, I will be talking about acids. Now the term acids have been derived from a Latin word which means sour because this is associated with the sour taste of the fruits. Now what is an acid? An acid is a compound which when dissolved in water, it produces hydronium ions as the only positively charged ions. Let's take an example. Let's take the example of HCl, hydrochloric acid. Now, when it is dissolved in water, it produces the ions H plus and Cl minus. That means it produces hydrogen ion and chloride ion. Now, this hydrogen ion then combines with the water molecule and it produces hydronium ions that are the H3O plus. That means hydronium ions are H3O plus ions. Okay, so in brief we can say acid is a compound which when dissolved in water it produces H3O plus ions as the only positively charged ions. Okay. Now, there are various categories on which we can classify acids. First category is on the basis of the source of acids. That means from where we are getting the acids. First one is organic acid. An organic acid is that acid which has been derived from plants. That means we get these acids from plants. Example, acetic acid, which is present in vinegar. Then, tartaric acid, present in grapes. Then, citric acid, present in lemon. Apart from that, oxalic acid is also an organic acid. So, we get all these acids from plants. Next is inorganic acids. Inorganic acids are those acids which we get from minerals. As these acids are derived from minerals, that's why they are also known as mineral acids. Example, hydrochloric acid HCl, sulfuric acid H2SO4 and nitric acid HNO3. These are the examples of inorganic acids. Okay. Now, next category is on the basis of the molecular composition of acids. There are two types of acids, hydroacids and oxyacids. Hydroacids, as the name suggests, it will contain one hydrogen and another non-metal. But this non-metal should be except oxygen. Okay? So, hydroacids are those acids which contain hydrogen and one non-metallic element other than oxygen. Example is HCl. See, here hydrogen is present, chlorine is a non-metal, so chlorine is present, here oxygen is not present. HBr is also a hydroacid and HI is also an example of hydroacid. Okay. Now let's see what are oxyacids. Oxyacids are those acids which contain hydrogen, one element, another element, and as the name suggests, it will contain one oxygen. Okay. Now, example of oxyacids are H2SO4, HNO3. Why? Here hydrogens are present, oxygens are present, and another element. In case of HNO3, nitrogen is present. In case of H2SO4, sulfur is present. So these are the examples of oxyacids. Next category is on the basis of the strength of acids. Now, what do you mean by strength? Strength of an acid actually depends upon the concentration of the hydronium ions that are present in the aqueous solution of an acid. And depending upon that, there are two types of acids, strong acids and weak acids. So let's see what are strong acids. Strong acid is an acid which completely dissociates in the aqueous solution. That means they dissociates completely in the aqueous solution and therefore they produces high concentration of hydrogen ions or hydronium ions. They produce high concentration of hydrogen ions or hydronium ions. Let's take an example. Example of strong acid is HNO3, H2SO4, okay, HCl. All these acids are strong acids. All these acids dissociate completely in the aqueous solution. See, HCl, when it dissociates in aqueous solution, then it forms H plus and Cl minus. Here one hydrogen is present, so one hydrogen has been dissociated. Okay, but in case of weak acids, they dissociate partially. In the aqueous solution, they dissociate partially, and that's why they form or they produce low concentration of hydrogen ions or hydronium ions. Example of weak acids are acetic acid, citric acid, carbonic acid. Let's take the example of acetic acid. CH3COOH. In aqueous solution, it dissociates into CH3COO minus plus H plus. Okay, so this acid is not dissociating completely, it is dissociating partially. That's why these acids are called weak acids. Next category is on the basis of the concentration of acids. Depending upon that, two categories are there. One, concentrated acids, another diluted acids. Concentrated acid means this is an acid which have a relatively high percentage of acid. This will have high percentage of acid, and dilute acids have low percentage of acids. Okay, this is the basic difference between concentrated acid and dilute acid. In aqueous solution, concentrated acids will have high concentration or high percentage of acid, and dilute acids will have low percentage of acids. Okay, next is on the basis of basicity of acids. Now, what is the basicity? Basicity means the number of hydrogens that can be produced per molecule of the acid in the aqueous solution. Or in other words, we can say that it is the number of hydroxyl ions with which one molecule of acid will combine. So, basicity basically means it is the number of hydrogen ion which can be produced per molecule of the acid, that too in an aqueous solution. Okay, clear? This is the basicity. Depending upon that, first category is monobasic acid, as the name suggests. This will produce one hydrogen ion per molecule of the acid. That means it will contain one replaceable hydrogen ion. Okay, example is HCl. This contains only one replaceable hydrogen ion. Apart from that, HNO3, CH3COOH, that is acetic acid, all these are monobasic acids. Okay. Next is dibasic acids. Di means what? Two. So it will contain two replaceable hydrogen ions. So it will produce two hydrogen ions in the aqueous solution. Example is H2SO4. This contains two replaceable hydrogen ions, right? Even carbonic acid is also dibasic acid, H2CO3. Similarly, tribasic acid means tri means three. So this type of acid will contain three hydrogen ions or three replaceable hydrogen ions, and they will produce three hydrogen ions in aqueous solution per molecule of the acid. Example is phosphoric acid, H3PO4. It contains three replaceable hydrogen ions. Clear? Now, there are two types of theories. One is the Arrhenius theory and another one is the Bronsted-Lowry or Lowry-Bronsted theory, which actually defines acid. According to Arrhenius theory, acids are those substances which dissociate in aqueous solution to give hydrogen ions. As I have already told you that strong acids will dissociate completely while the weak acids will dissociate partially. And according to the Bronsted-Lowry theory, acids are proton donors. Proton donors means, see, in case of HCl, what will happen? It will dissociate into H plus and Cl minus. Here, H plus is the proton. Here, the acid HCl is giving out H plus. That means Here HCl is donating this particular proton. That's why acids, according to the Lowry-Bronsted theory, they are proton donors. Okay. Now we will see how acids can be prepared. Acids can be prepared from non-metals like chlorine, iodine. These are the non-metals from which acids can be prepared. When hydrogen combines with chlorine, then it forms hydrochloric acid. When H2 reacts with iodine, I2, it forms HI. Similarly, when H2 reacts with bromine, Br2, it forms 2HBr. Okay. So from metals we can get acids. Similarly, from acidic oxides like CO2, SO2, SO3, phosphorus pentoxide, P2O5, from all this acidic oxide, when these acidic oxides, they dissolve in water, they form acids. Like when carbon dioxide reacts with water, it forms carbonic acid H2CO3. Similarly, when SO2, sulfur dioxide, reacts with oxygen, it forms H2SO3, sulfurous acid. When SO3 reacts with water, it forms H2SO4. When P2O5 reacts with water, it forms phosphoric acid H3PO4. Okay. Now, acids can also be prepared from salts. Normal salt of more volatile acids are displaced by a less or non-volatile acid. See, a normal salt like potassium nitrate or sodium chloride. Let's take the example of sodium chloride. It's a very common salt, a normal salt. When normal salt reacts with a non-volatile acid, like sulfuric acid is a non-volatile acid, then what will happen? It forms an acid salt and it displaced a volatile acid. See, it displaced a volatile acid. From H2SO4, HCl is prepared. From one non-volatile acid, a volatile acid is forming. HCl is a volatile acid and H2SO4 is a non-volatile acid. So when a normal salt like NaCl reacts with a non-volatile acid H2SO4 and when the temperature is less than 200 degrees centigrade, then it forms HCl, a volatile acid, and of course an acid salt, NaHSO, sodium bisulfate. Okay. Now, another method is by oxidation of nonmetals. Sulfur is a nonmetal. Okay. When this sulfur or when this particular nonmetal reacts with or oxidized by nitric acid, concentrated nitric acid, then it forms sulfuric acid, water and nitrogen dioxide. So here from one concentrated acid, another acid is formed. Only one thing that we have to keep in mind, this concentrated acid should be used to oxidize a non-metal. From sulfur, sulfuric acid is formed in this way. Okay. Now, what are the physical properties of acids? Acids are sour in taste in aqueous solution. Mineral acids are highly corrosive. Okay, they are very much harmful. Mineral acids like I have already told you, HCl, HNO3, H2SO4, all these acids are very corrosive. Okay, and when an indicator like litmus is an indicator. Litmus is an indicator. When this indicator is used, when a blue litmus paper is used, then acid turns blue litmus paper into red. If we dip a litmus paper, a blue litmus paper into a solution, and if then the blue litmus paper becomes red, then we can say that solution is acidic in nature. This is the physical property of acid. Next is the chemical properties. First is the neutralization reaction. What is that? When an acid reacts with a base, then it forms salt and water. What does the acid actually perform? Acid actually neutralizes the base. Acid neutralizes the base. See here, HCl is neutralizing NaOH. That's why it forms NaCl and water. Okay. NaOH is the base, HCl is the acid, it forms NaCl and water. double displacement reaction. Okay. Similarly, when dilute acids react with active metal like zinc, then it always liberates hydrogen. This is a very important chemical property of acids. When dilute acids, they react with active metal, for example, zinc, then they always liberate hydrogen. Okay. Now, acids, when they react with salt, they undergo a double decomposition reaction. See, NaCl, I have already told you about this. NaCl, when reacts with, I'm explaining only one reaction. NaCl, when reacts with H2SO4, concentrated H2SO4, okay, then what happens? This Na and SO4, NaHSO4 and HCl, double decomposition reaction. Sodium bisulfate and hydrogen chloride is formed. Okay. Next is the uses of acids. There are different types of acids like boric acid. Boric acid is used as an eye wash. Citric acid, which is present in lemons, oranges, they are used as food preservatives. Oxalic acids are used as ink stain remover. Carbonic acid, which is present in cold drinks, they actually used for flavoring the drinks. Tartaric acid used that are present in grapes, they are also present in baking powder. Acetic acid present in vinegar, they are used in cooking purpose, and hydrochloric acid are used for pickling of metals. These are the list of acids and these are the uses of those acids. Okay. So I think I have made myself clear and this topic is absolutely clear to you all. This is all for this particular lesson. I will upload the next lesson of this topic very soon. Till then, stay tuned to my channel. And if you think my videos are informative and they are helpful, then please like and share my videos and don't forget to subscribe to my channel. Thank you for watching the video.